Howdy. So we'll begin with this discussion with a brief introduction to the concept of abstraction and some other terminology that we'll use when speaking about user-defined types. So how would you describe a car? You might think about it in terms of its attributes, its appearance. What does it look like? What color is it? What make and model is it? How much horsepower does it have? Torque, etc. These are all attributes of the car. We can also, when we think about a car, begin to characterize it by its behaviors, what it can do. And how I might describe a car, which would kind of be at the right. I know very little about mechanics. Someone who's well versed in the nitty gritty details of, say, the different components of a car might describe it in a very different manner than I would. So this gets us to this first key term, abstraction. This dictates that some information is more important than other information, but does not specify a specific mechanism for handling the unimportant information. As a process, we will say that abstraction is going to denote the extraction of the essential details about an item or a group of items while ignoring the inessential details. As an entity, an abstraction is going to denote a model, view, or some other focused representation for an actual item. And we'll see how abstraction comes into play when we're thinking about modeling different things in our program. For instance, if we are doing some sort of CAD software, how we'd model a car might be at a completely different level than, say, in a car driving race car game. So how would we provide an abstraction of a car in code? Types are going to essentially be pretty good at directly representing ideas in code. For instance, when we want to do integer arithmetic, an integer type is of great help. If we'd like to manipulate text, as we've seen in some of the early MPs, a standard library string is of great assistance. Types are helpful because they provide both representation and operations for an object of that type. A type's going to know how to represent the data needed in an object. Operations, a type is going to know what operations can be applied to the objects derived from that type. So the natural question now is, well, how would we provide an abstraction of a car in code? So the concept of a car is going to follow this pattern. A specific car is obviously represented by different attributes. We can also perform various operations on cars, the result of which is going to be dependent on the underlying state of the object to which that operation is applied. For instance, a Ferrari should accelerate faster than a Honda Civic. We would like to represent an abstraction of our notion of a car as a user-defined type along with a set of functions that can perform car operations. What exactly is a user-defined type is what we'll visit in the next video.